Sam Zazra Total. We are from Group A S1G2. So our topic is brain tumor detection system using the AI. So our group member is Tan Yi, Horong Jie, me, Sun Wei Hong, and also the Liu Ken Yi. So let's go through the introduction and the problem statement. So the problem is diagnosing the brain tumor in the MRI image is difficult due to the complex structure and the subtle visual difference. So current issue is manual review by the radiologist is time consuming and prone to the human error, especially during the peak workload. So our solution is develop an automated CNN-based system to classify the MRI scan into the tumor or no tumor categories. So project goal is develop a reliable AI model and manage the development life cycle using a formal project management methodology. So let's go to the case study and the objective. Our target scenario is this is a tools for the hospital radiology digital support. So role of AI is it acts as a digital support tool. So it cannot replace for the doctors. It's just a tool to let the doctor be more efficiency. So what is the key benefit? First is it can reduce the diagnostic delays, enhance the diagnostic the efficiency and the workflow productivity, and also provide the instant confidence score for the prediction. So what software we use? We using the programming language which is the Python. The development environment we using a Google Colab and using the cloud-based with GPU support since it can is very efficiency. So the libraries we using the NumPy, the Matplotlib, Seaborn, and also the TensorFlow. So for our project plan, we using the Microsoft project to plan our project. The version control we using the GitHub to update our software version. So after the program, we using the deployment. We using the Gradle to deploy a web-based AI interface.
So for our work breakdown structure, we have 5 phases. The first phase is our project initiation, where we define the scope and the resource requirement. For the second phase, we have data acquisition. We gather MRI dataset and pre-process it. And the third phase is model development. It is for the architectural design and hyperparameter tuning. And fourth is the system integration. We do evaluation and the Gradio interface integration. And for the fifth phase is documentation. We do the final reporting and presentation preparation. For our cost and time management, our cost management is we utilize Google Colab to avoid hardware costs and also rely on open source libraries such as TensorFlow. We also follow a structured schedule across all 5 phases as shown here. For our risk management strategies, we implemented 4 of them, which is overfitting, whereby we mitigated by adding dropout layers and early stopping. Data balance, which is solved by using stratified data splitting. Training instability, which is countered by reducing learning rate. And deployment issue is handled by saving and reloading the stable H5 model. So for our monitoring and control, our choice of platform we use is GitHub, and we have a version control where we maintain a centralized history of all code changes. And we also use GitHub issue to assign tasks with implementing metrics and tracking bugs. And for our communication, the discussion occurs directly in issue threads.
Hello, Doctor. I am Tanji, and now I will walk you through the technical details of the system. For the system architecture, our system flow is straightforward. We load the MRI dataset, pre-process the image by resizing and normalizing them, build the CNN model, and finally deploy it. For the CNN methodology, we use the feature extraction, the 3 convolutional layers to extract features, and max pooling for dimensionality. For the regularization, We use the dropout layers to prevent the model from memorizing the data flow, which is called overfitting. For the classification, we use fully connected layers leading to a sigmoid output of 0 if no tumor and 1 if have tumor. The loss function is the binary cross entropy. For the training enhancement, the training elements used for this project are early stopping, which means the training automatically stops when validation loss stops improving to prevent the overfitting. Learning rate reduction. Learning rate is reduced when validation performance plateaus to improve convergence and stability. And finally, for the validation monitoring, validation data is used during training to monitor model performance and guide optimization. The metrics recorded for the project is accuracy, precision, and recall. Now I will pass this to Ho Rong Jie.
Okay, now I will continue present about the evaluation results of our system. So our training performance is training accuracy increased steadily according to the plot. Training loss decreased. Model learn effectively. Then you may notice some overfitting in the plot, but we have prevention mechanism here. So the prevention mechanism we are using is early stopping to track the validation loss. Our model will automatically save at post 29 where the validation loss was the lowest. So this prevents the final model from overfitting even though training continue. And the final result is test accuracy 96.89, F1 score 96.93. Shows the model generalized well to new unseen brain MRI scan. So this is our sample output of web interface. The tools we are using is Gradio, and we allow user to upload an MRI image. System perform a pre-processing and inference, and display the final result, prediction result, along with the confidence score. So the benefits of our system is user-friendly and real-time results. Let's come to the conclusion. So we successfully apply deep learning to detect brain tumor with strong performance, which means the high accuracy. Then about the integration, we deliver the model through a systematic and iterative process from data acquisition and pre-processing to model training evaluation, ensuring robust and reliable development. Then the impact is deliver a complete data to deployment life cycle, resulting in a work prototype for media precision support. That's all for the presentation of Group A. Thank you.
Someone suggested, Doctor, this is the demonstration part for Group A. So our topic is intelligent system improvement for the semantic segmentation and classification of brain tumor using deep learning. So this is the library we input. So we have Google Drive mounting here. So we put our dataset in the Google Drive, then mount the Google Colab to the Google Drive. Okay. Then we have 1050 for no tumor data and 1050 for tumor data image. Then we will start data loading and pre-processing. So we have image loading and conversion, resize and normalization and labeling. Next, we will split the dataset into three. First one is training, second one is validation, the third one is test set. Okay. Then we will come to the CNN model architecture and training. As you can see, we have several layers here. And we set our drop-down rate is 0.25. So next is model compilation setting. And we start our training process with training data, validation data, and we set the approach to 30. And we're also using callbacks during training. So we got early stopping. The patient is 10 approach. Then another one is reduced plateau. The patient is 5 approach. Next, we will go to the model evaluation and performance. As you can see, our accuracy is 96.89%, have a low loss rate, and this is a classification report analysis lah. So no tumor class we will label as 0, tumor class we label as 1. So next is confusion matrix analysis. Can see our model is doing well. The true negative and then true positive have a high rate lah. Then next is a training history broad analysis. We got model accuracy, model loss, model precision, and model recall. Okay. So overall, our model is doing well. We have a good balanced result, and we don't have underfitting and overfitting. Okay, then we demo the system now. Okay, so the web page will look like this. Then we put some sample to let the system predict. So as you can see, there are no tumor detected. The confidence level is 93 lah. And got a recommendation, regular checkup. And we put a X-ray with tumor. So tumor detected. Then we change another one. No tumor detected. Alright. Then the last one. Okay. So everything working well. That's all for the demonstration. Thank you.